Hello and good morning to you out there, wherever you are in the world. This is Samuel Anekan. Welcome you to this channel. So in this video, we'll continue our partial fraction lesson. This is our fifth lesson. We've had lesson 1, lesson 2, lesson 3, lesson 4 in different videos. So if you've missed out on those ones, make sure you go back and watch those ones. I'm going to put the link to those videos in the comments section. So partial fraction is actually a mathematics, further mathematics, additional mathematics topic, and depending on whatever exam you're writing, the knowledge can come in handy. So before we continue, if you're not subscribed to this channel, I will plead with you to hit the subscribe button and also hit the like button, because you are actually going to enjoy this video. So and get ready to drop your comments at the end of the video as well. Then click on the bell icon so that you always be notified whenever we upload a new video. Thank you so much. So we're going to start right away. So today we've looked at partial fraction. So we've looked at partial fraction. We've looked at various rules of partial fractions. So our first law when dealing with partial fraction is that the degree of the numerator must be less than the degree of the numerator. That is the coefficient of your variable. So let's say, assume if you have x raised to power 2 at the top, then you must have either x raised to power 3, x raised to power 4, x raised to power 5 in the denominator. If not, if it is otherwise, if the degree of the variable in the numerator is either equals to that in the numerator or higher, then you're going to use long division to divide the numerator by the denominator, and then you get the remainder r and the quotient q, and arrange them in this form. So you're going to have the quotient plus the remainder plus the divisor. Your divisor is what you have in the denominator. So this is what you're going to have. At the end of the day, you have a value for the quotient, you have a value for the remainder, you have a value for the divisor. We've actually applied this rule in our previous videos. This rule has been applied in one of our previous lessons. Okay, so this rule 1, whereby the degree must be less than, has been applied in our previous lesson, and we got to 1 when the degree was actually equals to, and we also applied it. So I think we treated 1 as well where the degree was higher than, and we also applied it. Yes, we applied it. So we had a situation where the degree was equal, and we applied this concept here. We used long division to divide and applied it. Then we also had a scenario where the degree of the numerator was higher, and we also applied it. We had two examples where the degree was less, and we solved it. Okay, so the next rule is that to each linear, let me write the rule down. So rule 2 states that to each linear factor in the form x minus a, in the denominator there corresponds a partial fraction of the form a over x minus a, where a is a constant. So take for example, you have 3x squared minus 4x plus 5. Now in the denominator, the denominator can be factorized to 3 linear expressions. We have x plus 1 linear, x minus 2 linear, 2x minus 1 linear. The highest power of each variable here is 1. X is raised to power 1 here, x raised to power 1 here, x raised to power 1 here. So you can actually, when you are expressing a partial fraction, in this case we have 1, 3. We have 1, 2, 3. You can have 2. Since we have 1, each of them is going to be a over x minus a. That is, in the first case, we are going to have a over x plus 1 plus b over the second one, x minus 3. Now we have a third one. There are scenarios where you are just going to have 2 and you stop here. Since we have a third one, plus c over 2x minus 1. And if in a scenario where you have a fourth one, then you are going to have d plus d over whatever you have, the linear factor that you have. So this is rule 2. We've applied this rule right from lesson 1, lesson 2, lesson 3, lesson 4. So the third rule is a rule we've not applied yet, which I'm going to state right now. So I'm going to state the rule and we're going to apply it. So we are going into rule 3 today. So let me write down. So we move into rule 3. So rule 3 states that to each quadratic factor in the denominator of the form ax squared plus bx plus c, which does not have linear factors, there corresponds a partial fraction of the form ax plus b over ax squared plus bx plus c, where a and b are constants, where capital A and capital B are constants, where uppercase A and uppercase B are constants. By being constant, they are numbers, pure numbers. Okay, so this is rule 3, whereby you have in the denominator a quadratic expression that you can't factorize it into linear factors. So what are you going to do? You're going to bring this, unlike the previous scenarios where we are having a over the linear factor, we're having something like ax plus whatever plus maybe b. But in this case now, you're going to bring in a linear factor at the top. So we are going to apply this right now. This is what we'll be looking at. We're going to deal with this in this lesson. So just stay tuned as we move on. So for our example here, resolve 3x squared plus 8x plus 13 all over x minus 1 into x squared plus 2x plus 5 into partial fractions. So we want to resolve this. Is it possible to resolve it? Yes, it's actually possible. But before we resolve, let's look at the denominator. We have a linear factor, x minus 1. So that part is going to be a over x minus 1. Then we have a quadratic factor here. Is it factorizable? Can we factorize this thing? X squared plus 2x plus 5. Can we factorize this into this form, into linear factors, into 2 linear factors? Let me see. We have 5, we have 2. Are there 2 numbers we can choose that when multiplied will give us 5 and when we combine them will give us 2? The only 2 numbers that will give us 5 are minus 5 times minus 1 will give us plus 5. And plus 5 times 5 will also, times 1 will also give us plus 5. But there is no how you combine 5 and 1 that it's going to give you 2. So this thing is not factorizable. So we are going to apply rule 3 over here. So this is going to be resolved as we have plus, in the denominator we're going to have x squared plus 2x plus 5. Then above here we're going to have a linear factor, b x plus c. So this is how it's actually going to look like. This is how, when we resolve, it's going to look like this way. So this is what we're going to resolve this fraction, this algebraic fraction. We have to put it in this form. So let's go ahead right now. So let's go ahead. Why did we bring in bx plus c? Because this is not factor. This is a quadratic expression that is not factorizable. This is where the rule 3 applies. This part is where the rule 3 applies. So the rule 3 is what brings in bx plus c. This side, x minus 1, is just a linear factor. It has just an a number, a constant. But this is quadratic, which brings in a linear expression there. So let's go ahead and solve. So we are going to set 3x squared plus 8x plus 13 all over x minus 1 in brackets and x squared plus 2x plus 5. We're going to set it equals to this. So we have a all over x minus 1 plus b x plus c, bx plus c all over x squared plus 2x plus 5. So we have this right now. Okay? So next, we go ahead and what is the LCM of this? The LCM of x minus 1 and x squared plus 2x plus 5 is x minus 1 into x squared plus 2x plus 5. So this is the LCM of this and this. Now, x minus 1 in the LCM, x minus 1 is going to cancel x minus 1. You are left with x squared plus 2x plus 5. So you now multiply a times x squared plus 2x plus 5. This gives you a into x squared plus 2x plus 5. Then we move to this other side. X squared plus 2x plus 5 in the LCM. This is going to cancel this one. X squared plus 2x plus 5 is going to cancel x squared plus 2x plus 5 in the LCM. You are left with x minus 1. So x minus 1 will go up and multiply bx plus c. So we have b x plus c multiplying x minus 1. So this is equivalent to this all over x minus 1 x squared plus 2x plus 5. So denominator is equals to denominator, numerator is equals to numerator. Okay, so what do? We're going to set the numerator. We need to solve for a, b and c. Once we do that, we'll come back here and substitute those values and we've actually resolved. So let's bring the numerator out. So bringing the numerator out, we have that 3x squared plus 8x plus 13 is actually equivalent to a into x squared plus 2x plus 5 plus b x plus c x minus 1. Okay, so how do we go ahead to solve this? How do we go ahead to solve this? So let's look for what we can eliminate. What can we eliminate here? Is there anything we can eliminate? So over here, if we can actually make this side 0. How? If we have x minus 1 equals to 0. So what will make x minus 1 equals to 0? Let's find out. X minus 1. If x minus 1 is equal to 0, then x is going to be equals to 1. So if we set x equals to 1, 1 minus 1 is 0. 0 times the whole of this part will become 0. So this part will disappear. Only this part will remain, and then we can now solve for a. So if we set x equals to 1 here, 1 minus 1, 0. 0 times the entire part. This part will disappear. The b will disappear. The c will disappear. Everything here will disappear. Because we are multiplying by 0, and 0 times anything gives you 0. So this part entirely is going to vanish. So we are going to be left with this part. So we can then solve for a. So let's do that right away. So let's go ahead. Let x equals to 1. So if x is equals to 1, what do we have? This is going to be 3 into 1 square plus 8 into 1 plus 13 equals to A 1 raised to power 2 plus 2 into 1 plus 5 plus, yeah, we have B into 1 plus C, then 1 minus 1. So 1 raised to power 1 is 1. 3 times 1 is 3. 8 times 1 is 8 plus 13. Then over here, 1 raised to power 2, that is 1 times 1 is 1. 2 times 1 is 2. Then you have 5 plus, there's no need wasting our time. 1 minus 1 is 0. 0 times this part, in bracket, everything here is going to be 0. So let's not even waste our time writing it out. Okay, so 3 plus 8 is what? 3 plus 8 is 11. Then 11 plus 13 is 24, equals to 1 plus 2 gives us 3. 3 plus 5 gives us 8. 8 times A gives us 8A. Let's discard the 0. 0 won't add anything or subtract anything. So we have that 24 is equals to 8A. So solve for A. 24 divided by 8, divide both sides by 8, gives us that A is equals to 24 divided by 8, which is 24 divided by 8 is what? A is equals to 3 at the end of the day. So our A has been solved to be 3. Our A is what? Our A is 3. So A is equals to 3. Okay, so I hope you have your pen and your paper and you are taking down notes. Right now I'm going to rub this off, because right now I want to solve for the next variable, either B or C. So I will go ahead, I will solve for C. I will make B 0. I will look for a way to make B 0 so that I can actually solve for C. So we go ahead with that. Our A is 3, which I have written up here. Okay, we've gotten our A as 3. So it's as easy as this. So whenever you are faced with such, look for a way. When you come over here and make this 0, everything here will become 0 automatically. So you can now solve for A. So start in that form. Start by making this side 0. Okay, so I rub this off right now, and right now we are going to make B 0. So what can make B 0 here? What can make B 0? If you set x equals to 0, 0 times B will become 0. So let's do that. Let x equals to 0. If x is equal to 0, then over here we have 3 into 0 raised to power 2 plus 8 into 0 plus 13, equivalent to A into 0 raised to power 2 plus 2 into 0 plus 5 plus B into 0 plus C, then 0 minus 1. 0 minus 1. This is our still x. So let's go ahead and solve. 0 raised to power 2. 0 times 0 is 0. 0 times 3, 0. 8 times 0, 0. Then you have a 13. 0 raised to power 2. That is 0 times 0 times 3, 0. 0 times 0 is 0. 0 times 3 is 0. 8 times 0, 0. You have 13. You write it down. Then A, 0 raised to power 2, 0. 2 times 0, 0. Then plus 5. Then over here, B times 0, 0.
0 minus 1 minus 1. 0 minus 1 minus 1. So 0 plus 0 plus 13 gives you 13. You have a into 0 plus 0, 0 plus 5, 5. 5 times a, this gives you 5a. Then you have this plus here. 0 plus c gives you c. C times minus 1 gives you minus 1c, which is the same thing as minus c. So you have minus c plus times minus gives you minus. So you have 5a minus c equals to 13. And what was that? We've already solved a. A was 3. So you put a equals to 3. You have that 13 is equals to 5, 3 minus c. So over here now, you have 13 equals to your 5a is what? 5a is 3. 5 times 3 is 15. Then, so solve for c. We bring c minus c to this side, it becomes plus c. We bring plus 13 over to this side, it becomes minus 13. So your c at the end of the day is equals to 2. So we've gotten our c as 2. C is equals to what? 2. So we're going to write that down. C is equals to 2. Okay? So no stress. So I believe you are still taking down your notes and you are actually enjoying the class. So I just want to remind you again, if you're not subscribed to this channel, make sure you hit the subscribe button, and I believe you are also enjoying the video. So click on the like button and get ready to drop your comments. I need your reactions. Either you enjoy the video, or maybe there are ways you feel I could have done better, or there are things you actually want done. So drop it in the comment section. Click the bell icon and set it to all so that you always be notified whenever I upload a new video. So we continue right now. We've solved for A, we've solved for C. It remains B. So I rub off again. So to solve for C, you can take any value. Since you already have A, you have C, you can assume any value for x that will give an equation that contains A, B, and C. Then you will now put the value of A and C, which you already have, and then solve for B. Or we can use comparing coefficients, the method of comparing coefficients. So we are going to compare the coefficient of x2, terms that are contains x raised to power 2. We are going to compare those coefficients of terms that contain x2. That's what we're going to do. So we're going to expand this part of the equation over here. Bx times x gives us bx squared. Bx times minus 1 gives us minus bx. Plus c times x gives us plus cx. Then plus c times minus 1 gives us minus c. Okay. So we have a times, we expand this aspect as well. We have a times x squared gives us a x squared. A times 2x gives us 2ax. A times plus 5 gives us 5a plus this one. So on the left hand side we have 3x squared plus 8x plus 13. So right now the only thing we need to solve for is B. To solve for C, I'll collect the terms, the coefficient of the terms that contains x squared. What are the terms that contain x squared? We have this one, we have this one, and we have this one. Those are the terms that contains x squared. Those are the terms of interest here. So for terms containing s squared, we have s squared such that, what is the coefficient of s squared here? That is 3. So we're going to equate what we have on the left hand side to what we have on the right side. Here, what is the coefficient of s squared? A. Over here, what is the coefficient of x squared? B. So we have this equation right now. So what do? We are looking for B. We've already solved for A. So we just substitute the value of A. We solved A. A is there. We got 3. So you have 3 plus B. So from here now, 3 minus 3 is equals to B. So your B is equals to 0. Your B has been solved and is equal to 0. So we've solved B and we got 0 at the end of the day. So we've successfully solved the question. We've gotten our B is what? 0. So it's as easy as that. So if you're having a little challenge, just rewind the video. Just follow the video to the end and go back with your pen and paper and start following it one after the other. In case you still have any challenge, just drop your comments in the comment section. And already my WhatsApp number is displayed here. That is +234 803829 5185. So if you have any problem, just drop it in the comment section and I will be delighted to actually help you. So B is equals to 0. So since we've gotten our value for everything, B, A, and all, so we are going to come back here to here. Our A is what? A is 3. So we have 3 over x minus 1. Plus over here, our B is what? 0. We have 0x. Plus our C is what? 2. X squared plus 2x plus 5. So, looking at this now, 0 times x will give us 0. 0 plus 2 will give us 2 there. So for that side we have 2 over x squared plus 2x plus 5 plus 3 into x minus 1. So we've successfully resolved 3x squared plus 8x plus 13 all over x minus 1 in bracket and x squared plus 2x plus 5. We've successfully resolved it into partial fraction. So it's as simple and easy as this. So I'm going to do one more example using this method in our next lesson. That will be lesson 6. So watch out for lesson 6. But before we go into lesson 6, I'm going to write the question I'll be solving so that you try it by yourself. And when we come next time together, in the next lesson, you will actually use it to confirm whether you are actually correct. You actually use next lesson to confirm whether your answer is correct. So let me drop off the board and drop the question. So our assignment is resolve 2x squared plus 2x plus 10 over x plus 1 in bracket times x squared plus 9 in bracket as well into partial fraction. So x squared plus 9 is actually your quadratic expression here. So the middle term in the quadratic expression is missing. So don't be confused. This is x squared. This is general form of the quadratic expression. This is this part. This is this part. this part is 0, so it's still a quadratic without that middle part. As far as this is available, this is a quadratic. That is what makes it a quadratic. So go ahead and solve this, and in the next thing, look for it. I'm going to also solve it so you compare your answer with mine and actually know whether you are right or wrong. So with this right now, we've come to the end of this lesson. So please, if you know you're not subscribed, go ahead and hit the subscribe button. And I believe you've enjoyed the video, so click on the like button as well, and click on the bell icon, set it to all, so that you always be notified whenever I upload a new video. So watch out for our next video. And also, we also have videos on physics, so share our videos with your friends, with your families, and share it with others, and give us the publicity as well. So in case you need a one-on-one lecture, I'm available. Just contact me from my WhatsApp number, which is a +234 803829 5185. If you need a one-on-one lesson, whether online or offline, I'm available for it. So God bless you. Bye. We're meeting in the next class. Thank you.